Yo, what's up guys? So today we're going to be talking about equations and relations. So I'm a little sick today, so if my voice sounds off, just ignore it. So let's get right into it. So the first part, or at least first thing we're going to talk about are equations, okay? So basically what are equations and some definitions surrounding them. So just two introductory ones I'm not going to write down because it's a kind of a big definition. An open sentence. So a mathematical statement that contains algebraic expressions and symbols is called an open sentence. And a sentence that contains an equal sign is an equation. So, 2 videos ago we talked about algebraic expressions, and something like 3x plus 7 would be an algebraic expression, right? But 3x plus 7 is equal to 13 is an equation. And so the goal of an equation normally is to find the value of a variable, and this is called solving an open sentence. And the value of the variable is called the solution. Okay, so pretty basic terms, but let's kind of get more complex. So a set of numbers from which replacements for a variable may be chosen is called a replacement set. And I'll explain what that is in a sec. A set is a collection of objects or numbers that is often shown using braces. And each number in this, or each value in the set, is called an element. And a solution set is the set of elements from a replacement set that makes an open sentence true. So let's figure this out. How about we use this equation right here? So I'm going to set up a little table right here, and so we have our replacement set right here, which is in the brackets 1, 2, 3, and 4. And so what we're going to do is we're going to plug each of these elements, so each of these elements, into the equation to see which ones work. And we're just going to say if it's true or false. So if we plug 1 in, that's 3 plus 7, which is 10, so that's not 13, so that's false. Then let's do 2. That's 6 plus 7, that is equal to 13, so that is true. Fix that F. Here, I'll fix that F. And let's look at 3. So that's 9 plus 7, which is 16, so that's false. And then 12 plus 7, which is 19, so that's also false. So in this case, we only have one value that is true, and so our solution set is going to be just 2. Sorry, that was a bad 2, but so this is going to be our solution set. Okay, so let's try this equation, okay? So remember, we're still going to go with orders of operation. So obviously this side here, the 24, completely simplified. There's nothing else we can do with that. So now we're going to just start simplifying this side. So let's do the 3 squared. So we have 4 times n plus 9 minus 20 is equal to 24. Because we can't combine a variable and a constant with addition, what we can do here is we can distribute. So we have 4n plus 36 minus 20 is equal to 24. And we continue to simplify. So we have 4n plus 36 minus 20 is 16 is equal to 24. I'm going to teach you a very important property of equation. We're going to assume that 4n plus 16 is equal to 24, right? So we're going to look at this, okay? So let's substitute it, okay? Let's substitute it. So we're going to say 24 is equal to 24. So we're going to substitute this side for 24, right? So now that we have something like this, right, if they're equal, then what if I want to change this? What do I want to say? Okay, well, I want to make this side 20. So I could subtract 4, right? But that would make it 20 is equal to 24, right? But if I subtract the same amount on this side, so I subtract 4 on this side, we're left with it still being equal, right? So we can subtract 4 on both sides, and we get a true statement. True, that was supposed to be a check mark. So let's try with something else. What if I want to say I want to make this side 6? So we can divide this by 4. And remember what I said, if we do something to this side, we have to do it to this side. So if we divide both sides by 4, we get 6 is equal to 6. So that is correct. So we can apply that same concept over here, that whatever we do to this side, we have to do the same thing to this side. And what we want to do is we want to get n by itself to figure out what n is, right? So we can take away this 16, but we have to do the same thing to this side. So we have to subtract 16 from both sides. So we get 4n is equal to 8. And then here we have an even simpler equation here. We're like, okay, well I just need this n by itself. So how can we get 4? How can we get the 4? Because remember, it's 4 times n. How can we negate the 4? How can we cancel it out, basically? Well, you guys may be aware of reciprocals. So if we have a over b times b over c, or sorry, b over a, that's equal to 1. So if we have our 4 over 1, we can multiply that by 1 over 4 to get 1, and that makes it 1n. So we can do that by multiplying it by 1/4 or dividing it by 4. And whatever we do to this side, we have to also do to this side. So we get n is equal to 2. So we took this and we simplified it to n is equal to 2. So this equation may have been slightly complex, but I think it kind of taught you many of the valuable aspects of solving equations. In this section we talked about simplifying it using order of operations, and then in this section we talked about the properties of equations and how when you do something to one side you have to do the same to the other. And so using a combination of those we can solve much of our equations. Now there's one more key term I want you guys to know, and it is called identity. So what's an identity? Well, an identity is an equation that is true for every value of a variable. So what does an identity look like? Well, here I'm going to go up here. So an identity could be as simple as 4x is equal to 4. And you're like, okay, well yeah, obviously they're equal to each other, but for every value of x, this is true. So a lot of the times you're going to get an equation where you can get a variable on one side and you can get a value on the other. But let's try to get the variables on one side. So 4x, and if we try to subtract them, we just get 0 is equal to 0, which is also true. So this is called an identity because for every value of x, or whatever variable, the expression is true. And I like to call this a true identity. Let's work with having a variable on both sides. So we could do 4c plus 6 is equal to 8c minus 4. And so, what I've been doing a lot is moving it to the left side, but it could be on any side you want. I like to move the smaller variable to the bigger variable side because I don't like having negatives. And when I say move the variable, I really mean canceling it out, or like making it 0 on one side, so that there's a variable on the other side. So let's move this 4c by subtracting 4c. So now that's equal to 0, so it's 6. And now we have 4c over here, so 4c minus 4. And now let's move the constant, so we add 4 to it to make it 0. And we have to add 4 to this side as well, so we have 10 is equal to 4c. And then now we're going to make this 4, this coefficient, equal to 1 by dividing it by itself. So you divide this by itself, and this simplifies to 5 over 2, or 2.5, is equal to c. So that is our solution. So now we're going to be talking about relations. So it starts by talking about a coordinate system. So you may have seen something like this, right? And you may have seen some graphs. So maybe maybe you've seen a company's like profit graph. Maybe dip a bit, maybe something like that, right? Or it might be going down. It can be doing whatever. But this is called a coordinate plane. A coordinate plane is the intersection of two number lines, the horizontal axis and the vertical axis. It's basically just two number lines. Okay, these are just two number lines, one going up, one going up and down, one going left and right. The one going left and right is called the x-axis. Let me make a better X. An x-axis. And the up and down is called the y-axis. And the very middle is called the origin. And the origin is represented by this pair, 0, 0. And so this is called an ordered pair, and it is written in the form parentheses x comma y parentheses. So let me give you an example. Let's say we have 1, 2, 3, 4, 5, 6, 7, and we have 1, 2, 3, 4, 5, 6, 7. And we would have maybe something right here. So how can we find the spot that is how can we find the ordered pair of this variable? So let's draw a line straight down from it, okay? And so it and let's see what x value intercepts. So that's 1, 2, 3. So we know that first part is going to be 3. And then let's draw a horizontal line and see what y value it intercepts. And that's 1, 2, 3, 4. So we know that that point it can be represented by the ordered pair 3, 4. It has an x value of 3 and a y value of 4. And so when you have multiple ordered pairs, so when you have a set of ordered pairs, that is called a relation. Mapping is how you illustrate the connection between the ordered pairs, the coordinates of the ordered pairs. So when you have remember how I said that an ordered pair is x comma y, so it's an x coordinate, y coordinate. Well, usually the x coordinate is called the domain. X coordinate is called the domain. Y coordinate is called the range. And so mapping is kind of how you connect the domain to the range. So if we were to have a set of ordered pairs, if we were to map this, which I said before is kind of connecting the two, then we would have in our domain, we can just call it D. How about that? We have -2, -1, 0, 1, 2, and then we have our values. So we have 4 in our range. So we have our range. So we have 4. We have also 4. So we're not going to write duplicates. We have 6. We have 8, and then we have 8 again. So we're not going to write duplicates, like I said. And so mapping is basically just drawing arrows between the two, so we can see the correlation. So if I were to just do that, oh shoot, sorry, the 0 goes to the 6, and then the -1 and the -2 go to the 4. So this is kind of how we can see the correlation between the two. So just from the pair, it looks like right now is that if the domain's 0, the range is 6. If the domain's below 0, it is 4, and if the domain's above 0, it's 8. But I could never know unless I have more data points, and it could always change. So you need basically infinite data points to be 100% sure. But that's where functions come in, which can order it in a very organized way. But that's for another video. So the final thing I want to talk about is how you can kind of connect the two. So the domain is usually the input, and if you notice, they're very set. These are very ordered values. We have -2, -1, 0, 1, 2, so it's in steps by 1. Your domain is called the independent variable. The independent variable is one that you kind of do on purpose. It's kind of your input. It's what you set it to be. The dependent variable, which is the range, depends on what the independent variable is. So it's normally the independent variable is the input, the dependent variable is the output, and that will be very important later. Hey guys, so thanks for watching. So today we just talked about equations and relations. And so next video we'll be preparing to talk about functions and different types of functions. So, if I skip something or didn't explain something well enough, feel free to comment. And if I notice that a lot of people are commenting about a certain concept that I didn't explain well, maybe I'll make another short video covering it. But yeah, I'm always open to feedback. Consider subscribing if you like this content. Sorry guys, had to deal with my sick voice today. And again, thanks for watching, and peace.